G'day, KC here, and how you doing? In today's video I'm going to continue to show you how I design the clocks, and we'll keep moving through on the Planetary gear clock. So I started the design with the base, and my printer, the bed of my printer is only a 300 by 300, so I wanted to do quite a nice size clock. So I started off, so that's how it would stand up, and that would be the top dial, and then the other two dials would be here. And so I was allowing myself places, and then these are where the screw holes would go through to screw it all together. So that's where I started. Later I realized just how big the clock would be, so I resized it so that it would fit on the biggest size that would fit on my build plate. Also, it was difficult to get all those pieces to line up straight. So it was just easier if the base of the clock was just one piece. So this is later what I came up with, and this was the base plate that I started. And then the idea was to then start putting the gears on it. But this actually gave me an idea for, well, an idea of the size. So I had 3 pictures of gears, and this is actually sized in accordance with the gears that I had. So let me talk to you about sizing the gears and how I designed the gears. So to design the gears, I found drawings on the internet, and that were a similar size that I thought would work on the base plate that I had sized already. But the only gears I had was an 8, a 16 and a 36. So I actually measured their diameters, and then I also measured to see if I could get the pitch circle, what I estimated that was. And from that I plotted those 3 onto the graph over here. So it was the pitch and the diameter, and I thought they'd be a straight line, and they were. And actually, with hindsight, it's actually the modulus. That's actually what I'm plotting here. So if I just done a bit more research and homework, I probably could have saved myself some time. But from these graphs, I then drew a line through them, and got the equations, the trend line. From the trend line, I got the equations for these. And from that, I was then able to pick any tooth size, and then I was able to work out from that equation the diameter, the pitch circle, and the pitch radii. So that's really how I designed the gears in the beginning. And then I would use these sizes in Fusion 360 to draw the gears. So this is a drawing or tracing that I did of one of a tooth of those 3 gears that I had. So really all I'm doing is I'm copying these this tooth to make the gear. So let me show you how I do that. So So all I need is to find the center of the gear. Just draw a line. I just want to offset that line. And the gear was, the 16 tooth gear was 26.1 millimeters. So that means the center would be 13.05. So now I know that that is the center of the gear that I need. And from those equations, that's how you can pick up the center of any of those gears and their dimensions. So if I grab a circle, and you can see there the dimension is 26.1. So now let's make the gear. So we make that by just really copying these teeth. So circular pattern, select the objects. So let's zoom in on these objects. That one, that one, that one. And we need the top of it as well. All right. So why I needed that center point is the function needs the center point. So where's the center point? Well, I can either click that or it's the center of the circle. And there it tells me, do I want 3 teeth? No, I actually want 16. So if I just keep, and this is exactly what you do for depending on how many you need. And there you go. And now I've got my 16. So I click OK. Then just put another circle out to there. And that's basically how you draw it. So just, to clean it up. And there we have a gear. And you can then do whatever you want on the center. So I'm going to make a 2 millimeter hole. And really that's just how you would draw it. Now when I started, I was also a bit of a beginner to Fusion 360, but actually now there's a far easier way of generating gears, any size, any modulus, so you can actually work far easier with them. And it's in this function, utilities, add-ins, run. It'll add it to your panel. So if we come across to create, we'll see the spur gear has loaded there. So we're going to use that. And coming across metric, yes, I want a metric gear, pressure angle 20. The module, we remember back on the spreadsheet, the module that we got was 1.45. And depending on how you adjust that depends on the size of the gear. So the number of teeth in the module gives you the overall size of the gear. So ours was a 16. No backlash. Our root fillet radius is too small. That's that little thing there. Because the gear is so small, so what we'll do is change that to half. I usually like to do 3 millimeter gears at least, and the hole can be 2 millimeters for an M2 cap screw. So what I'll show you here is a 16. If I change the module, your diameter will go up. So let's change this to 5. And you'll see now it's an 80mm gear. So our module from our spreadsheet was 145. And so the pitch diameter is 23.2, even though the total gear diameter will be 26.1, hopefully. So let's see how accurate we are. And there's our gear. All right, let me just move that down. And look at that, that is spot on, almost exact. So my old way of doing it took a lot more time and effort, but it wasn't bad. Whereas now in the future, I'm just going to use the spur gear application and generate the gears. Just makes it so much easier. And then you can draw on this plane if you want to make holes or spokes or anything you want. Thank you so much for watching, and take care, and God bless. Thanks again for watching, and be sure to like and subscribe as it helps the channel to grow.